Continue on with 9.2 in our confidence intervals for means. We're going to do this example on top of page 7. A simple random sample of 51 mortgage companies is taken and their current interest rate are recorded. So what's 51 going to be for us? N. It's how many people we asked or how many companies we looked at. The sample mean rate. So since it's a sample mean, what can we label 6.93 with? You got it. With a standard deviation of 42. This is what's different. We're used to labeling standard deviation with sigma, but remember we don't know sigma. This is the sample standard deviation. What was its symbol? S. You got it. So notice right off the bat, we have most of our unknowns for the formula. It says if the distribution is normal, find the 99% confidence interval for the mean rate. Interpret your results. So I'm going to do it again by hand just because some people like to do it by hand. But on your test, you guys don't have to. Just tell me what you type into your calculator. That's fine. So I'm just going to steal, it's sad, but I have it memorized. I'm going to steal from the other page. Our lower bound, guys, is starting with our point estimate, x bar. The average rate's the best place to start. Minus our critical value, t alpha over 2, times our standard deviation over root n. Okay? And our upper bound will just be the positive version of that. So let's go ahead and fill in what we can automatically. So what was our sample mean rate? 6.93. Minus our critical value, let's leave a gap. We'll come back and fill him in. What was our standard deviation? 0.42. Over the square root of our sample size, which was 51. You got it. Okay? So the one thing that you guys will not be told on both 9.1 and 9.2 are the critical values. So Z alpha over 2 for proportions uses your gray sheet. T alpha over 2 for means is going to use your golden sheet. Okay? So when we look at this, how are we going to come up with it? Again, I kind of do this little footnote off to the side. What does 99% confidence mean? It means 1 minus 0.99 equals 0.01 for the tails total, right? 1 minus 0.99 means 0.01 for the tails total. But what do we have to do to get for one tail? Divide by 2. So again, it's that whole inverse idea. So we're going to look up an area of, what's that end up being? 0.0050. Is that okay so far? So 99% confidence means we better be confident. We're going to almost take up the whole graph. So it leaves an area of 0.005 in one tail. What else do we need to know? We need to know what row to go to. So this tells us the column. But we need to figure out what row to go to, and that's based on your degrees of freedom. Remember, your degrees of freedom are n minus 1. So what are our degrees of freedom going to be? 50, right? We're just going to take 51, our sample size, minus 1 and get 50. And that will tell us what row we need to go down to. Okay? So we're just trying to locate the correct critical value. So this chart I think is easier than the gray chart. Go down to row 50 and scroll over to column 0.005 and you'll find your critical value. So we're going pretty far over. What do you guys get for your critical value? 2.678. Yep, 2.678. Let me talk to you about this for a second. We happen to land perfectly on 50, but you know when you get down here and you're close, you're just go by tens, go to the thing that's closest. So say our degrees of freedom were 44, then you would go to row 40. Okay? Or if it was 69, go to row 70. All right? Go to whatever it is that's closest to it, the next best thing. All right? So what we're going to do is we're going to let our mean rate of 6.93% hang out, subtract, and we're going to calculate this by putting that in our calculator exactly how we see it. So go ahead and put 2.678 times 0.42 divided by root 51 in your calculator. Let's round to 2 decimal places. What do you guys get for your margin of error? .1, so like 0.16 if we rounded to 2 decimals, that's okay. 0.16. What does that mean? It means our average interest rate, like if you were to go buy a house, the average interest rate is 6.93%, give or take 0.16%. So we're going to go ahead and subtract that. I think you get 6.77%, all right? And then our upper bound, guys, is just going to be the addition of that, okay? You start with your point estimate of 6.93, and then you're just going to add your margin of error of 0.16. So you get an upper bound of 7.09%. All right, so hopefully somewhere in there you have room for that sentence, right? So you can say I am, but I typically say we are, okay? We are 90% confident. We are 99% confident the true population mean lies in the interval 6.77% to 7.09%. We are 99% confident the true population mean lies in the interval of 6.77% to 7.09%. And stop and ask yourself, what did you just find? You are pretty sure that the average interest rate in the U.S. are between those two values. So if you go to a bank and they try to offer you 8.2%, you say no. No, there's a 1% chance that you're going to be that, and that's awful. I'm going to go somewhere else. On the other hand, if somebody offers you 5.2%, you jump on it, right? You're like, oh gosh, I got to take advantage of this. So this whole idea, guys, is instead of using that sample average to estimate rates, we now are 99% sure that the true rate's between those two. Is it exactly in the middle? No. It could be 7.03%. Or it could be 6.99%. We don't know what the actual rate is, but we're 99% sure it's somewhere in there. Okay? The last note before we get to objective 5 is just that sometimes outliers throw off your results. So to be more accurate, a lot of times you will just throw them out. And also to get more accurate without changing your confidence level, always increase that sample size. Remember, sample size, the closer you are to the population, the better. All right, so the last concept just mimics chapter or section 9.1, guys. 9.1, we learned how to do the point estimate and the confidence intervals for population proportions. But then we said, okay, how do we find n? It's the same thing here. We did point estimate x bar for the mean. We did a confidence interval for the mean. But the question is, how do we find n? So what we're going to do here is we're going to do this value where we're going to do n equals, so anytime you have to find sample size, you look for that n equals formula, but this is for estimating the population mean, okay? It's z alpha over 2 times s over e. And it's kind of tricky because everything we've done with means has been on this golden sheet, so it's t's. And now all of a sudden we're throwing a z back in there. But why can't we use the sheet? What do we need to know for our degrees of freedom? What's the formula for degrees of freedom? Do we know n? No. So what's the next best thing? Z. And if you don't have z, what's the next best thing? T. They're kind of interchangeable, okay? So since in this case we don't know n, we would not know what row to go to get our t alpha over 2. So we're going to use the next best thing, z alpha over 2. All right, so on A it says, and don't forget, we're going to always round up. That's that weird rounding rule. It says a recent Gallup poll asked Americans to disclose the number of books that they read during the previous year. Initial results indicated that S equals 16.6 books. So right there they told us S, guys, which is nice. So we have one thing already to fill into our formula. How many subjects are needed? So how many subjects, what are they asking for, guys? They're asking us to find N. And that's what you have to pay attention. You are going to be on a roll in chapter 9, finding all these confidence intervals. And then you're going to try to do a confidence interval, but you don't know N. It's because they're not asking you to find a confidence interval. It's one of these problems. They're asking you to find N. So how many subjects are needed to estimate the number of books Americans read the previous year within 4 books? Within 4 books is going to be our E. That's our margin of error. Meaning, I want to be accurate, give or take 4 books of the true proportion. Or the true average, I should say. All right, I'm going to write the generic formula. N equals, parentheses, Z alpha over 2 times S all over E, and the whole thing is squared. Z alpha over 2 times S all over E, and the whole thing is squared. Let's go ahead and fill in our S and our E, because they are obviously given to us. Let's leave a gap to fill in our Z. We'll come back to it, okay? our S was 16.6, our E was 4 books, okay? So this is a little bit different. On Wednesday or Monday, and I know if you haven't gone to do your homework, you probably don't even remember, but on Monday, since we were dealing with proportions, our E, our margin of error, was always in percents. So you put 0.05 or whatever. When it's a mean, it's just the whole number. How many books do you want to be close to? Within 4 books. So just put 4 down there. You don't have to change it to 0.04. All right, how do we find Z alpha over 2? Again, let's just do our little footnote off to the side. What is your Z and T always based on? Your confidence. All right? So does anybody remember what 95% confident meant? 5% outside, which leaves 2.5 on the one tail. So 1 minus 0.95 leaves 0.05 divided by 2 tails. So we need to look up on our Z chart, our grade chart, an area of 0.0250. And this is one that's pretty common, so you might get familiar with it. You actually can find an area of 0.0250 perfectly. What is it? 1.96. And remember your critical values, you never use the negative, right? So it's going to be 1.96. And then don't forget, after you do all this math on the inside, you must square it, okay? So 95% confidence means 5% for the tails, or 2.5% for one tail. So we want to see how close we can get to 0.025. It goes with negative 1.96, but we don't care about the negative. So multiply 1.96 times 16.6, divide by 4, square it. You should get, was it 66.16? Yeah. Okay. But again, this is how many people we need to ask. So can you ask 0.16 Americans? No, but is 66 Americans enough? No. So what do we have to round to? 67 Americans. So if we really want to be 95% confident when we do our confidence interval and be within 4 books, like so our margin of error would be 4 this way, 4 that way, our N would have to be 67. Okay, we'd have to ask 67 people. All right, I'm going to leave this up here so we can do the second part on the top of page 8. It's the exact same idea. So let's read on the top of page 8 what it says. It says, how many subjects are needed? So again, what is it asking for? N, to estimate the number of books Americans read the previous year within 2 books with 95% confidence. What's the only thing that's going to change on our formula? E, right? Instead of being within 4 books, we want to be within 2 books. So on the top of page 8, guys, can you go ahead and put N equals, and write this formula, 1.96 times 16.6, but all over 2, parentheses squared, okay? Because our standard or deviation is still the same, it's 16.6. Our level of confidence is still 95, so our Z alpha over 2 is still 1.96. The only thing that changed was we want to be a little bit more accurate. We want to be within 2 books now. So what do you think is going to happen to our sample size? Will it decrease or increase if we want to be more accurate? Increase, right? If we want to be more accurate, we better ask more people. All right, so while you're calculating, I'll catch up with you. N equals 1.96 times 16.6 all over 2, the quantity squared. When I do that, I get 264.65. Does that look right? Yeah. So that's going to round up to 265 Americans. All right, so if you want to be twice as accurate, so instead of being within 4 books, you want to be within 2 books, your margin of error is a lot smaller, you better ask more people. And so kind of that's what C is asking. It says, what did doubling the accuracy do to the sample size and why? It increased the sample size, right? It actually quadrupled. Because in order to be more accurate, you must ask more people. So if we want to be within 2 books of the true mean, we'll have to make sure we ask more people, aka increase your sample size.